In this video, I'll show you how to integrate trigonometric functions containing tangent and sine with odd powers. To tackle products of tangent and sine or cosine, you can rewrite it in terms of sine x and cosine x using the following identity. The question asks us to find the integral of tan²x sine x. So the first thing that I'll do here is convert this tan²x into the following. The integral of sine squared x over cosine squared x times sine x. Don't forget the dx. Next, I'll multiply this sine squared x with this sine x, and this gives me sine cubed x over cosine squared x dx. My next step is to convert cosine squared x into cosine to the power of negative 2x. So we have the integral of sine to the power of 3x times cosine to the power of negative 2x dx. And the reason why I'm doing that is because, remember, if you have 1 over x, that's the same thing as saying x to the power of negative 1. And similarly, if this was squared, this would be negative 2. Now we have a trigonometric function that's odd and one that is even. So what I'll do is break this odd powered trigonometric function into two trigonometric functions that look like this. Sine x times sine squared x times cosine to the power of negative 2x dx. Now remember the identity cosine squared x plus sine squared x is equal to 1. I'm going to change sine squared x into 1 minus cosine squared x, which is equal to sine squared x. I just took this over, and so I end up with sine x times bracket 1 minus cosine squared x cosine to the power of negative 2x dx. I'm going to assign my u as cosine. So u is equal to cosine x. And watch what happens. If I take the derivative, I end up with du is equal to negative sine x dx. Solving for dx, I get du over negative sine x. So I'm going to rewrite this now in terms of u and du. We have sine x, that hasn't changed, bracket 1 minus u to the power of 2, u to the power of negative 2, and this becomes du over negative sine x. This cancels out, and this negative will be pulled outside of the integral, where we have bracket 1 minus u to the power of 2, u to the power of negative 2, du. We still haven't taken the integral yet. I'll use the distributive law to multiply this into the two terms to its left, where I have negative, the integral of u to the power of negative 2, minus 1. Look at this. U to the power of 2 times u to the power of negative 2. That's like saying u to the power of 2 plus negative 2. U to the power of 0 is 1. Don't forget the du. Now I can finally take the integral of both of these terms. The integral of this is easy. Add 1 to negative 2 and put this number underneath. And the integral of 1 is simply u plus c. Now I'm going to multiply this negative inwards. And the sign for the c doesn't matter, where I end up with u to the power of negative 1, these two negatives cancel out, plus u plus c. Now using the relationship I showed above, this becomes 1 over, and I'm also going to replace this u back with what I had it assigned, cosine x plus cosine x plus c. You can stop right there, or you can combine these two terms, but it's not important. This right here represents the integral of this function. And there you have it. That is how to integrate trigonometric functions containing tangent and sine with odd powers. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.